Hello, I'm Domenico Cipriani, and I would like to thank the organizer of ESUG, of this beautiful conference, and I would like to thank the Pharo Association for having sponsored my work in the last year on Phausto, Koipu, and all this musical stuff. So today I will talk about Turbo Phausto, and first I will introduce Phausto, then we will see what is Turbo Phausto, then we will see some updates about Phausto, and then what is on for the future, okay? How many of you know about Phausto, remembers about Phausto? Okay, half, kind of. So Phausto is a library and API that allows to program the DSPs, digital signal processor, in Pharo, okay? So we have a Faust architecture. Faust is a programming language for DSP programming, and we can embed an architecture inside our application. In this case, we can embed it inside Pharo, and we can do FFI to manipulate this Faust program. So there is a Faust compiler embedded, and there are these FFI calls. Why we started developing Phausto? So the first thing was to reach Pharo with sound, because until now Pharo was kind of mute. I don't know if anybody has made sound with Pharo before. Nobody? Yes? Kind of not so good. And then the other thing is to enable sound artists and musicians to program their synthesizer and effects with Pharo, so to attract other people to use Pharo. And then also it was think about teaching DSP programming that sometimes is very hard to learn. Faust is a functional language, is very powerful. It has a huge library, but it's very opaque, kind of. And it's easier than traditional DSP programming in, let's say, C++. That is a standard for audio development. So this is a situation also that there is a problem when you go to audio developer conference about students or people that doesn't know how to program DSP, doesn't know how to program audio, because C++ is a great barrier, and also Faust is a kind of barrier, even if it's less. Then we have other languages like C major that try to make things easier, but with Phausto we can do things even easier, I guess. And I want to show you an example of putting the sound inside Pharo. So we present a paper with Gabriel Darbord, a student, a PhD student at Lille, and we put sounds into Pharo with method proxies. So for test. Okay. So it's easy now with Phausto to put sound into Pharo, and it's even easier now with method proxies to having a connection with instrumentation, so we don't have to put Phausto methods or classes inside our codes, but we can do it through instrumentation, so our code does not explode like it would have been last year. Okay, so going back, what is Turbo Phausto? Turbo Phausto is a set of synthesizers and effects made with Phausto that is intended to go with Koipu, okay? So Koipu is the other library and DSL that I'm developing to program music on the fly with Pharo. But until last year, you only could use Koipu with an external audio engine. So it could be some OSC program like, I don't know, Pure Data or Max MSP or Chuck or Super Collider or external media hardware, but not within Pharo. What does it mean? It means that now having this Turbo Phausto thing that is modeled and inspired by the Super Dirt audio engine for Super Collider, we can have an all-in-one environment for Pharo, for live coded music and algorithms. So people can perform just with Pharo. And it comes with this synthesizer and effects, and it comes also with a folder of 50 megabytes of high-quality royalty-free samples made by me, the analog cops, that is me and my mate Mariao, and the legendary Dutch producer Legovelt. I don't know if anybody knows here. No, Legovelt. Legovelt is very good. He's much more famous and good than me. I asked him, can you donate your samples to Faro and to Phausto? He said yes, but please put my PayPal so they can donate to me if they use it and they like it. Okay, so we have this extension. We have a lot of folders. You have to download the folders of Turbo Phausto samples, and inside every folder you have a different amount of samples. You have the classical like kick drum, tambourine, tom, bongo, conga, snare. You have clave, cowbells, open hi-hat, close hi-hats, and the sounds are very good. So it's you start Turbo Phausto, okay? You send the message start to the class, and you load all the instrument and the synthesizer and the effects. Then you assign this Turbo Phausto instance of the class to a variable, and this is like inside it as both a DSP that is controlling the parameters of the synthesis and for both the effect and the instrument, and inside it has also a performance, and the performance is taking care of dispatching the FFI calls that then plays the instrument, okay? So if we see inside, if you can see the code is a little bit small, but inside start, we are loading the samplers, we are loading the synth, we are loading the filters that are on the master section, and we are loading this kind of, it's called a rack. So basically, for the samplers, it's going to the folder, and you say, okay, for each folder of sample, I create a sampler that you can access with the name of the folder. So with kick, you go to the kick folder. With conga, you go to the conga folder. Then you load a set of synths that I prepared for Turbo Phausto. Of course, you can define yours and add yours. Then the idea is to have like a super class for Turbo Phausto. And so the people can then directly implement their own version of Turbo Phausto and not having to modify the Turbo Phausto code. But for now, it's like that. So then you load the filters. You have an high-pass filter and a low-pass filter on the master rack. On the master bus, let's say, you load an effect. In this case, is a free verb from the Phausto library. And then this load rack is basically summing all the sampler and all the synths, connecting to the filters, connecting the filters to the reverb, and then to the stereo output, okay? So this was about Turbo Phausto. We can see a little bit of Turbo Phausto here. So it should be already started, so we can ask for the kick. Let's start from scratch. So you have the name of the instrument, and you have, for example, you have this Speak Spell folder that is the Texas Instrument Speak and Spell, the popular game for learning spell of the 80s. And you can access different, just with different, these index are going to the different samples inside the folder. So you have to access the samples inside the folder with a number that is their index. They are sorted in alphabetical order. For now, it's not possible to call each file with its name. It's a little bit to stay with the same design as tidal cycle, but it could change in the future. So you have these instruments, and you have also synthesizer like this acid clone of 303 that is now playing a cumbia clave and then arpeggiating two chords. And then you have, for example, also a classical Hoover sound. So one of you that were raving in the 90s know what is that. Okay, so this was all about Turbo Phausto for now. And now we have a little update about what has been happening in Phausto in the last 12 months. So we have 190 tested classes from the Phausto standard library. We want to have it all, but at the moment we have all the oscillator, filters, synths, reverbs, delays, saturators, modal percussion, string instruments, wind instruments, demo, synthesizer, and demo effects, all the math that you can do in Phausto. You can do in Phausto now. You also have 20 classes from the basic library. The other are in the work. It was a lot of work. The test is basically just testing if the DSP can be created. When you create a DSP, basically on the underlying Phausto compiler, there is a pointer that becomes a struct, so it receives some information. If the pointer cannot be created, the test fails. So this is basic test. We cannot incite the creation, but this is for how the Faust architecture is done. We have more stability thanks to Seba. Now, when we create a DSP, all the unit generators become unit generator null objects. Okay, this is because when in Fausto you create DSP by connecting unit generators, and then you send a message as DSP. But in the underlying Faust compiler, in the Faust architecture, is creating a context for the compilation, and then is destroying the context. And it destroyed all the unit generator that you created. And so when you were trying to recreate a DSP with the same unit generators, the unit generators were null pointer, and Fausto was crashing, Pharo was crashing, and so it was a big problem. Most of the Fausto crashes that are still there are caused because the dynamic engine is written in C++, and the C wrapper around it was done very fast by Stefan Sletz that asked me about this project, and then he say, if you want to change something, it's up to you. So it's up to me for the future work. We have more tools that are like PH Capture and PH Looper. I will show you PH Looper what is now. And then we have Fausto lists that we don't have in Faust, but so we can create a list of number of unit generators. We have a selector, and we have a random positive low frequency oscillator. Let me show you the looper if it works. So we can call for deep, no, sorry, looper. Looper, we initialize the looper, we start the looper, we want the UI of the looper. Looper, ESUG, 2025. Okay, so this was the looper. It's fun if you want to play real instrument and record yourself and use like doing drones with your sound or doing kind of crazy performances. Then we have, in the last year, there were a lot of UI widgets created with block and tuple. Most of them by students like Yanis, a student from India, and also Alexis, that was a student working in an internship at INRIA. And so we have knobs, we have this clone of the 303, we have a keyboard, we have different buttons, we have kind of mixer sliders, so if we want to control the levels of the performance, and we have also a visualizer for waveforms, okay? So we can also visualize waveform, and in the future we could have like a DJ app made with Fausto. Also, we can now export DSP developed in Fausto into a C major patch. C major is a procedural audio language that was created also with the purpose to make DSP programming simpler and easier, but still not so easy. And I must thank Cesar Ferrari of the C major team, because he told me with a wrapper, and basically in Faust you cannot export a polyphonic DSP. In Fausto you can. So you can just write your DSP code in Fausto, you export it to a C major patch, then this C major patch, using their wrapper, you can load it in your digital audio workstation. So this is a step toward developing audio plugins without having to write C++. Also, we have exported to Bela. Bela is this embedded computer for sound with very low latency. It was created with sound artists and musicians in mind, so we can write our DSP in Phausto, and then we can export it to a special C++ written for Bela, and you can load it into the Bela editor, and then you can use your sound, your DSP into the Bela board without having to bring your computer. So you have your own instrument running. The Bela also has support for USB, so you can connect to the Bela, for example, a MIDI keyboard, or you can control it with open sound control support. Then also, I developed for a workshop I did at the Festival of La Robotica di Pisa, this Eco Phausto. So Eco Phausto is a lighter version of Turbo Phausto that is designed to work with Windows and Linux without an audio interface. So I noticed that when you're using Turbo Phausto, when you're using Turbo Phausto with Windows without audio interface, you have a lot of glitches. So that is due to the very bad audio performance of Windows. Not so bad on Linux, but okay. And so you can also use Eco Phausto for Windows, and this was also done for like teaching purposes, because so you have a system that can work even if you have like computers in a school or in a lab that are not so powerful. And then we have this new tool that has been developed by Ocean during his internship at EVREF starting in April, and you can connect different instruments, okay? And then so it's a graphical tool to connect and program DSP with Faust. At the beginning, only with given instruments, modeled after the Faust playground. So you have this Kisana, you have harps, you have different stuff, and you have different effects. But in the future, the idea is to apply this environment to the construction of DSP with simpler unit generator. So to have an environment a la Max MSP, to say, pure data. So this is the first step. It looks very Windows 98, but she liked it, so you have to live with that. So about what is happening in the future, we have to have the full coverage of the Faust standard library. We need everything that is there, that is possible to have there. Then we want to have a graphical representation of what you are creating inside the DSP, because now you create a DSP, you connect unit generator, but from your playground is like a black box. You don't see what is connected with what, and so it's difficult to kind of debug your DSP if the sound is not right. So we have to have this graphical representation. We have to have, for the toolkit, sequencers, so that allows you to play sequence of notes or whatever. And then we have to add additional exporter, like the ones we have for C major and for Bela. We need for Rainbow, that is the low-level API for Max MSP, for Super Collider, and we would like to have it for the Shark audio modules, that is a very powerful DSP platform for programming audio. So this will allow. Sometimes we were testing how many reverbs can we open with Faust, how many oscillators can we have. Yes, depends on our CPU, but of course, if we are doing things seriously, we cannot rely too much on the audio of the computer itself, so we need to do it outside. So this is for the future. And of course, we have to rewrite some of the C++ codes of the C wrapper to have no crashes and to have full MIDI and open sound control integration, because this is the way that Phausto DSP can connect to the world. And I want to thank all the people that helped me with Phausto. If you have any question.